Standard solar system models depict a predictable machine of perfectly balanced orbits, but data shatters the symmetry. Mars is stunted, a massive asteroid debris field drifts, and Uranus tilts at 98 degrees. Earth formed in a thermal zone too hot for ice, yet oceans exist. These anomalies are the direct physical result of massive gravitational forces. They are the scars of an era defined by chaos. The stable, predictable system we see today is merely the settled wreckage of a 4 billion-year cosmic pinball game. This process began 4.6 billion years ago within a vast cold cloud of molecular gas. A nearby supernova sent a massive shockwave through the region, forcing the cloud to collapse under its own weight. Most of that material, nearly 99.8%, condensed at the center. As the pressure spiked rapidly, the core ignited into a 27 million degree ball of plasma to form our sun. The remaining debris flattened into a spinning disk, baking in the center while freezing at the outer edges. In the hot inner zone, only rock and metal clumped together, while in the deep freeze, massive cores swept up hydrogen and helium to become gas giants. This separation of rock and gas created a massive gravitational imbalance, leaving the system's largest actors primed to move. The early solar system was a fluid environment, thick with gas and friction. Jupiter, driven by its own massive gravity, began to move. Jupiter spiraled inward like a gravitational snowplow, clearing the inner system and sweeping away the material Mars needed to grow. This inward slide only stopped when a gravitational resonance with Saturn acted as a tether, pulling Jupiter back out. Earth exists today only because Saturn's mass halted that inward slide. Without it, Jupiter would have consumed every rocky planet in the system. The NICE model suggests shifts in Jupiter and Saturn's orbits violently shoved Uranus and Neptune outward into a dense ring of icy debris. This intrusion destabilized the region, scattering trillions of comets out of their orbits and hurtling them toward the sun. This triggered the late heavy bombardment. For millions of years, a torrential swarm of icy comets and asteroids rained down on the inner rocky planets. This period of mass impacts was the ultimate delivery mechanism for the ingredients required to make the inner solar system habitable. The comets of the late heavy bombardment were rich in water. As they slammed into the barren early Earth, they released the steam and vapor that would eventually form our oceans. Over millions of years, friction from remaining space dust and the pressure of the solar wind cleared the remaining debris. The wild, elliptical orbits of the planets slowly settled into the stable circles we see today. The sun now protects this fragile layout. Its outward solar wind generates the heliosphere, a massive magnetic bubble that shields every planet in the system from interstellar radiation. The serene equilibrium we experience now is the direct, settled result of that ancient gravitational war. In 2026, space missions are specifically designed to read the record of this early upheaval. Instruments like the James Webb Space Telescope peer across deep time to watch the birth of other star systems, comparing their development to our own. Our return to the moon aims to study the impact evidence from the late heavy bombardment, preserved for billions of years in the lunar soil. The orderly solar system we inhabit is a temporary, hard-won illusion. Understanding how it survived this chaos helps us identify which distant star systems might actually be capable of hosting life.